Have you ever wondered what would happen if someone quietly solved one of aviation's biggest problems, while the rest of the world was still arguing about how to do it? Because that's exactly what happened. In late 2024, something incredible took place that barely made international headlines. China commercially certified a 4-seat electric airplane called the RX4E. And here's the crazy part. It wasn't just another flashy prototype or a concept shown at an air show with dramatic music and fancy animations. This aircraft was legally approved to carry paying passengers. Meanwhile, companies across America and Europe have spent billions of dollars over the last decade chasing the same dream. They've hired former NASA engineers, Boeing experts, and aerospace geniuses. Their aircraft fly beautifully during test flights, but they still can't operate commercial services because regulators are busy writing the rules for electric aviation. Imagine training for a marathon while someone else quietly crosses the finish line before the starting gun officially fires. The RX4E has already appeared at international air shows, signed real customer contracts, and is preparing for large-scale production outside China. That's not a future promise, that's today's reality. But before you think this is just another China built something first story, the real surprise isn't the airplane itself. It's the problem this aircraft is trying to solve. A problem that has frustrated pilots, flight schools, and aircraft owners for nearly 70 years. And believe it or not, that problem has a familiar name: the legendary Cessna. Yes, the aircraft trusted by generations of pilots around the world. Reliable? Absolutely. Iconic? Without question. But beneath that legendary reputation hides a growing financial headache that the aviation industry simply can't ignore anymore. And that's where this story becomes truly fascinating. Now let's talk about the airplane almost every pilot on Earth knows: the Cessna 182. If airplanes had a Hall of Fame, this machine would probably have its own VIP parking spot. The Cessna 182 first took to the skies back in 1956, and believe it or not, it's still being produced today. That's nearly 70 years of proven reliability. Pilots trust it, mechanics know every bolt inside it, and if you land on a remote dirt runway somewhere, chances are you'll still find someone who knows exactly how to fix its famous Lycoming engine. That's an incredible achievement. But here's the problem. While the airplane has aged like a classic, the costs have aged like luxury hotel prices. Buying a brand new Cessna today can cost anywhere between $550,000 and $650,000. And that's just the beginning of the bill. Every single hour this aircraft spends in the air burns around 14 gallons of aviation gasoline, costing nearly $100 in fuel alone. Add insurance, routine maintenance, hangar rent, inspections, and suddenly flying starts feeling less like a hobby and more like paying college tuition every weekend. Then comes the engine overhaul. After roughly 2,000 flight hours, the Lycoming engine needs a complete rebuild, often costing $30,000 to $50,000. It's basically the aircraft equivalent of saying, "Congratulations, your wallet is now on life support." When everything is added together, operating a Cessna typically costs around $150 to $250 per flight hour. Now imagine running a flight school with 5 or 6 airplanes flying several hours every day. Students might pay $200 to $300 for a lesson, but most of that income disappears just keeping the aircraft airborne. One unexpected repair, a jump in fuel prices, or even a few canceled lessons can wipe out your profits for the week. And as if those costs weren't painful enough, there's another issue hiding inside the fuel tank, one that has become impossible for the aviation industry to ignore. But the aviation industry isn't just fighting rising costs anymore. It's also facing a fuel problem that has been hiding in plain sight for decades. Most small aircraft, including the Cessna 182, run on aviation gasoline, or avgas. Unlike the fuel in your car, avgas still contains lead. Yes, the same toxic substance that was removed from regular automobile gasoline years ago because of its harmful effects on human health and the environment. In 2023, the U.S. Environmental Protection Agency officially identified lead emissions from piston engine aircraft as a public health concern, putting even more pressure on the industry to find cleaner alternatives. Unfortunately, switching isn't cheap. New unleaded aviation fuels are available, but they cost around 30% more. And at some airports, especially in places like California, prices have climbed close to $7 per gallon. Instead of getting cheaper, traditional flying is becoming more expensive every year. So the aviation world found itself asking one big question: is there a better way? That's where electric aviation entered the conversation. Over the past decade, several Western companies poured hundreds of millions of dollars into building electric airplanes. Brilliant engineers from NASA, Boeing, and SpaceX joined startups like Beta Technologies and Aerospace, believing they could transform the future of flight. And to be fair, they built some incredible machines. Their aircraft fly, complete demanding test missions, and showcase amazing engineering. But there's one problem they couldn't engineer their way around: paperwork. Beta Technologies has already logged more than 125,000 nautical miles in flight testing. Yet, despite all that progress, its commercial aircraft still has to wait for certification, with timelines stretching into 2026, 2027, and beyond. Until then, those aircraft can only fly under experimental certificates, meaning companies cannot legally sell passenger flights or build a commercial business around them. Then there's Aerospace. Flight schools placed deposits years ago, expecting deliveries much earlier. But certification kept slipping, leaving customers still training on aging Cessnas while waiting for the electric future they were promised. And while the West was still waiting for regulators to finish writing the rulebook, someone else quietly finished the exam. So why did China move ahead while many Western companies are still waiting? The answer isn't that Western engineers lack talent, far from it. The biggest difference is the certification process. Building an airplane is incredibly difficult, but getting approval to carry paying passengers can be even harder. Every electrical system, battery, motor, software update, and emergency procedure has to prove it can handle countless real-world situations. Regulators simply cannot afford to make mistakes when lives are involved. In the United States and Europe, the rules for certifying electric aircraft are still evolving. Since this technology is new, regulators have had to create entirely new certification frameworks instead of adapting old ones. That process takes years, and companies are forced to wait while the rulebook catches up with the technology. China took a different approach. Instead of waiting until the aircraft was finished, its aviation regulator worked closely with the development team throughout the project. Engineers and regulators solved problems together as the aircraft evolved, making the final approval process much smoother. But here's something many people don't know. The RX4E didn't appear overnight. Its story actually began almost a decade earlier. Back in 2015, researchers in Shenyang, China, developed the RX1E, the world's first fully certified electric aircraft. It wasn't a giant passenger plane, it was a small two-seat trainer, but it gave engineers something priceless: real-world experience. While many startups elsewhere were still presenting concept designs and investor presentations, this team was already flying, testing, collecting data, and learning from every flight. Over the next 9 years, they improved battery technology, refined power management software, strengthened lightweight carbon fiber construction, and expanded thousands of hours of engineering knowledge. By the time work on the RX4E accelerated, they weren't starting from scratch. They were building on nearly a decade of proven experience. Then came the moment that changed everything. Between 2019 and 2024, 3 RX4E prototypes completed more than 1,200 flight hours and 1,800 takeoffs and landings under demanding test conditions. Every weakness was identified, every problem was corrected, and every improvement made the aircraft stronger. Finally, on December 29, 2024, the RX4E achieved full commercial certification, becoming the world's first certified 4-seat all-electric aircraft legally approved to carry paying passengers. And that was only the beginning of an even bigger global strategy. Before we wrap up, here's a question for you. If someone handed you the keys to a brand new Cessna and an RX4E for the exact same price, which one would you choose, and why? Let us know in the comments, because this debate is just getting started. If you enjoyed this video, smash that like button, subscribe for more amazing technology stories, and ring the notification bell. Until next time, keep looking up, because the future of aviation isn't just taking off. It might already be waiting at the gate with a fully charged battery.